So hello, everyone. Thank you so much for being here with Antalpha's series of account abstraction sharing events. So in case you don't know, we are a Antalpha Labs. We are a host of community developer community events, including hacker houses. And we are going to host our Montenegro Hacker House in this coming May, from the May 18th through 24th. The sign up has already started, so I think we're going to share the link in a bit. But today we are very honored to invite SoulWallet over to talk about ERC4337 and their product. So in case you don't know, SoulWallet is one of the biggest smart contract wallets. And the main difference from like a traditional external owned account wallet like MetaMask is that it has like lots of rich features, including like multi-factor authentication, social recovery, and like gasless payment, you name it. And SoulWallet is also like the recipient for the ERC4337 grant. And so how about we just hand it to Wei and maybe do a quick introduction and get us started. Thank you so much for being here.
Okay, thank you for inviting me to join this session. And you have to do a lot of research about SoulWallet. It's a great honor to be here. And I'm David from SoulWallet team, and I'm working on the smart contract side. And today I'm going to talk about a topic about ERC4337 and account abstraction and the smart contract wallet and their challenge as well. And as you may know, there are two account types on Ethereum right now. The first one is external own account, which is known as EOA, and it is secured by private key using ECDSA signature. And anyone who has this private key can control this address, which means if your private key gets hacked, and there is no way to replace the private key. And on the other side, the smart contract is a piece of code that deployed on the Ethereum network, and it is written in Solidity or other language, and it can add customer logic on top of that. So it means it's not limited to ECDSA signature verification. We could add like a quantum resistance signature verification, or even using biometric like fingerprint verification if possible. So the smart contract can have a lot of flexibilities to add a programming logic on top of that. And it can also implement his own replay protection. Like EOA, there is a linear nonce. If user send a new transaction, the nonce increment by 1. But with smart contract, you can have a two-dimensional array. So you can unlock a lot of possibilities. And there is a problem is like in Ethereum, all transaction has to trigger from a UL account, even with the smart contract. What if I want to have a smart contract wallet, but without care about this, like a UA account? There are other solutions before the ERC4337, and it basically by introducing a new EVM code, and this requires the protocol change and can be very risky to modify the consensus code. But with ERC4337, we can achieve this account abstraction, and the user don't have to manage a separate EOA to send their transactions. And how to achieve that is by ERC4337, it introduced like several roles. The first is user operation. This one is more like a normal Ethereum transaction. And there is another role called a bundler. The bundler role bundles the transaction and sends the user operation to the entry point. And the entry point is a global verified contract, and it should be heavily audited because the entry point, with the entry points, the bundler can make sure they will get paid by bundling the user operations. So the entry point requires the smart contract wallet to implement basically two interfaces. The first is validate the user op, and the other is execute op. The validated user op is for entry point to keep track of the maximum potential operations that the contract could be possible use. And the bundler, when he picks the user operation, he will simulate this validated user op. If the validation pass, and so the bundler will make sure their work is they done is what is worthwhile, and they can pick the user operation. And the execute user op is for the smart contract to execute arbitrary data, and the entry point use the execute op to keep track how many gas for this user operation spent, and later the smart contract wallet can pay the gas to the bundler. With this system, the user can have a smart contract wallet without manage a separate EOA, because the bundler take care of it. And it also create a decentralized network because everyone can be a bundler by running the bundler software or service. And the ERC4337 also introduced a paymaster role, and it can have additional verification logic to validate a paymaster user op. If this verification pass, the paymaster could pay the gas on behalf of the smart contract wallet, and it can unlock a lot of possibilities. For example, the smart contract wallet, it could implement a ERC20 paymaster, and if the verification pass, the smart contract wallet will pay the ERC20 to the paymaster, and the paymaster will pay the native token to the bundler. With this, smart contract doesn't need to have the native Ether, but also to send transactions. Yeah, with ERC4337, the smart contract wallet, it can unlock a lot of use cases like a social recovery, because we can add customer logic, and also transaction batching, which impossible in EOA account. This is especially handy when user interact with DeFi project, because if user want to swap some token on the DEX, the first thing they need to do is send approve transaction to the protocol, and then later they send a actual swap transaction. With transaction batching, the user operation can batch all these actions into one user operation, and the user only need to sign one transaction for that. And with the paymaster, it can achieve seamless user onboarding. For example, a lot of protocols have their issue their token for the governance, but it can also unlock the possibility if a user could stake a certain amount of the token to their protocol, and the protocol could pay the gas fee on behalf of the users if the user use their protocol, and also the ERC20 paymaster. And as we talked before, so I think it's very useful for the business side, because in the business side, it's very easy to keep track using stable coins other than like the native Ether. Here is an example of SoulWallet implement the social recovery. Yeah, the social recovery wallet is a single key that can be signed a transaction. It's basically act like a normal EOA. There is a key to manage transactions, but if the key get lost or get hacked by others, there is a way to replace the signing key by achieving, we can set a list of guardians. If certain threshold are met, like a majority of the guardian agree to sign the replace transaction, and we can, without using the original sign key, the guardians can help to replace the original sign key and set a new one. And in SoulWallet, we achieve it, and we also implement a concept about anonymous guardian. Instead, we set the guardian address directly on chain. We implement a guardian module, and this model is act like a multi-sig wallet, and it take a list of guardian address as the init code, and we implement the multi-sig module, and using the 32 counterfactory address, so we can calculate this multi-sig address, and we store this address on chain. With this, we can have a benefit because the user sets the guardians, and other people can't see who is your true guardian because this is a hashed address. But when user really need to recovery, they can ask their guardian to sign the signature for him. And the guardian cannot like talk to each other before you actually request the recovery. Yeah, here is the like implementation detail. If you're interested, you can check the GitHub. And here is another important example about SoulWallet implement the transaction batching. And we cooperate with a project called Waha. Here is an example, as you can see. This is a batch transaction that user using the RV protocol. And for like before the account abstraction, people usually send a approve transaction. And after this transaction confirmed on the blockchain, he actually send another deposit transaction. But with transaction batching, all these two actions can combine together in one user operation. Or like this is very like handy for like a DeFi yield farming or other project. Like right now, it's very popular on Convex, like a curve-like protocol, and people can just use USDC to do the curve deposit and get the curve LP token, and deposit LP token to the curve Convex protocol, and then etc. So the transaction batching is very powerful, in my opinion, and it also have a huge UX benefit because the user only need to sign one transaction. With the account abstraction, it can achieve many like use cases, but for the smart contract, it also has several challenges as well. Like the smart contract could have the problem when interact with the app front end. And also for some DeFi protocol, it block the smart contract user on their protocol level. Like in their Solidity, it doesn't allow smart contract user to use their protocol. And I will talk about this in detail. And also there could be problem if the smart contract wallet user expand to multi-chain, and the address consistency could be a huge problem. For example, a user have a smart contract wallet on layer 2s like Optimum. If later he want to explore other layer 2s like Arbitrum or zkSync, and the address consistency could be a problem. Even we could technically deploy the same like smart contract address on different chains, but it also have some like tricks to deal with it, and we will talk about this later as well. And for the state consistency, is also a huge problem or challenge. Imagine people have multiple smart contract wallet across different layer 2s. What if they want to do social recovery? Does he need to recover their wallet one by one on different chains, which means he will ask the signature to their guardians for each chain, and it is huge UX nightmare. And here is an example shows, like statistic shows the DeFi protocol which support the 1271 for signature authentication in their website. As you can see, not so many projects support the ERC4337. The 1271 is especially for signature verification in the smart contract wallet, because smart contract wallet doesn't have a private key behind that. Unlike EUA, there is a ECDSA sign message. So if smart contract user interact certain DeFi protocols, and in the front end, it gets blocked. If it need to get mass adoption for the smart contract wallet user, the DeFi protocol, especially the front end, need to consider to use the ERC4337. And the next part is more. The next part is more tricky. Is like how to, because ERC4337 can support can support a feature is like counterfactual address. It allows user can have their address without their smart contract deployed on the chain. So the ERC4337 cannot verify the smart contract which didn't deploy to the network yet. But what if we have a smart contract user which he didn't active their wallet yet, but still try to explore certain DeFi protocols? With the ERC4337, it's impossible because it needs to have the contract deployed to the network, and it required to check its valid signature in the interface. Luckily, there is possible solutions called 6492. It requires, with this like ERP, we can verify the counterfactual contract wallet address without deployed to the network yet. But it is, with this protocol, it still need to like gradually for mass adoption. So this could be a problem for the smart contract user. And the third is an example. Even the top DeFi protocol like Uniswap is not smart contract user friendly. In their front end, they have a check if the core data equals the response core data. If not equal, he will pop up alert to warning the users. This like for the ERC4337 other like a relay similar like OpenGSN network. If people using this kind of scheme, and they could have this security alert, and when they using their smart contract, so it's not very user friendly as well. And also, besides the front end, there could be a challenge on the protocol level on different DeFi protocols. For example, some DeFi project, when they write their smart contract code, they add this TX origin equals message sender check, which will prevent the smart contract users. I think this is especially common on the NFT project when they write in their minting contract. I think the purpose for them to add this check to prevent a Sibley attack, but it also block the smart contract user to interact with their protocol. And someone tweet about this as well too. If like smart contract get like a mass adoption, and when we write the smart contract, we also need to consider the smart contract user, and for example, to avoid this kind of check. And here is another challenge for the smart contract expand to multi-chain. As I said before, it's technically possible that there is a schema called create2. It allows to deploy the same contract across different chains. but it requires the same initialized code. What if the user have used their smart contract for a long time? Later, they do a social recovery to replace their original signing keys. But if he wants still using the same address, it could be problem if later they want to have the same address on a new layer 2, because the create 2 has to use the same initialized code. And it could be problematic. We assume user always have the same address. And also, even with the create 2 factory, certain chains doesn't support it. For example, Celo or Avalanche doesn't allow to send a pre-send transaction without chain ID. So there is no unified create 2 address on that. This is also very challenging. If we assume, we tell user they could have different address across multiple chains, there could be another challenge because the user could missend the fund to other chains. For example, they have address on the native on the Ethereum native chain. He could just copy paste and missend their fund on Optimism, for example. But in this case, we can there is a solution for that. Is add a tag before this address. But it's also, I think this is also need to have adoption. And the other thing is, if we assume we let user know they have to have different address across chains, but it could be a problem for them to bridging their assets, because most bridge right now, they assume their target chain is the same address as the source chain. With a different address implementation, it's hard for user to using the bridge service in right now. And it also has a UX challenge because the user have to manage different address on multi-chain, and it also a UX overhead to tell user to manage different address. Okay, another challenge is address consistency, state consistency is how to synchronize state on different chains. For example, as I told before, if user have smart contract wallet in different chains, what if they perform the social recovery? Does he has to recover one by one on each chain? And then it needs to require the guardian to sign the signature for them. It's a huge UX challenge. And it could be solved by introducing a unified cross-chain message across different layer 2s. But right now, every layer 2 has their own cross-chain message solutions. So it's very hard to have a unified bridge cross-chain message passing solution that there is an anchor chain if some state change, and this state change will automatically trigger the state on different chains through the unified bridging message. And this is also a very challenge and need to be discussed in the future. Maybe we could propose the layer 2 to have their unified standard bridging passing message format, but it's another scenario for that. Okay, I think that's all my talk. Any questions?
Thank you so much, Wei. And now we're on to the Q&A session. Definitely feel free to just unmute your mic or just type something in the chat, and we can relay the question for you.
Okay.
So someone's asking, will you see the slides? Is the slides going to be shared?
I could publish the link later.
Yeah, sounds good. And also, we are recording this event, and after this, in case you want to check out some of the contents, you can also watch our recording. And we see another question from Melissa. So he asked, do you see the ERC4337 equivalence in the future of other protocols?
Other protocols, can you specific like in other blockchains, or I'm not quite get the.
Yeah, I think it's in all other blockchains. She just replied.
Yeah. I think zkSync also adopts the ERC4337 concept, and they have their native account abstraction built on their protocol side. So it introduced a concept about how to validate the user op signature, and also has the very similar schema like a paymaster in zkSync implementation. I think the idea can be borrowed and implemented in other protocol.
There's another question, which is, what's the difference between native account abstraction of layer 2 and Ethereum? I think you just partially answered that question. Maybe just elaborate a bit more, say on like other layer 2s.
So I think the native account abstraction is you write the, you can add the coding logic on the consensus, because on the Ethereum, all the transaction has to trigger from the UA external account, which is impossible to for the smart contract to send the transaction without the protocol change. But with the native account abstraction, we can assume the smart contract can initiate the transaction. And the ERC4337 achieve account abstraction without the protocol change, without modify any EVM. And it is high-level abstraction by introducing the bundler role and entry point in this way. And the bundler can get the Ether because they can trust the entry point if they verify their work, and they will get paid. And we can assume the smart contract wallet can send transaction.
Sounds good. Thank you for that one. And we have two more questions. The first one is, which of the mentioned challenges do you consider the hardest to solve? And what do you think is the biggest blocker for mass adoption?
I think the last two are biggest challenge is because user right now are familiar with the UAs, because the UA is naturally support multi-chain. They always have the same address across multiple chains, but with smart contract account, and it's very hard to achieve the same concept. But it's technically possible, but also a challenge as well, because in my slides are shared. In order to have the same consistency address, the initialized code has to be the same, which is very hard, especially if some smart contract wallet support social recovery, which requires, it's very hard to keep the same initialized code later if it deploy this address to a new chain. And also for the state consistency is very hard, because right now for different layer 2s, there is very hard to passing message on each other. And the smart contract on each layer 2, the state are separate. If we could have a unified solution where passing message on different layer 2s and to solve the state synchronization issue, it could be a huge benefit. But it's also very challenging to implement this cross-bridge messaging protocol.
Actually, on that, I do have a follow-up question. So in terms of the cross-chain messaging, are there like already third-party type of solutions that like map protocol or like notify? Like I'm not super familiar with your products, but is it just that I haven't implemented the solutions for the new layer 2s, or is it just not working for some reason? Could you elaborate on that?
Yeah, there could be another like a bridge protocol that has the unified like bridging, but I think it's more important for the it has a native bridging like Optimum. They have their native bridging solution, and for the Arbitrum for their bridging, because their bridge also supports the cross messaging. If they have like a unified interface, and we could have like some way to aggregate this native bridging, it could be more trustworthy. This is my personal idea.
So it sounds like it's most about trust in terms of the messaging, and that definitely makes sense.
Yeah.
Thank you. We have more questions here as well. So, Tomo just asked, which EVM chain do you think have the best support for account abstraction right now, and mostly in terms of the bundlers, the mempool, and the entry points, etc.
Yeah, in SoulWallet we have like integrate with Arbitrum, and initially we try to launch on Optimum, but it has some like technical problem before their Bedrock update, because in their Optimum before the Bedrock, it's very hard to their node doesn't support the customer error message, which the bundler could not run their service. So we switch to Arbitrum, because every layer 2 has slightly different on the technical implementation. And for example, in the Arbitrum, when we implement it, and when we try to call the estimate gas on Arbitrum, and he will return the L2 gas together with the L1 gas cost. But on the other hand, in the Optimum, it only requires the gas cost purely on layer 2. So each layer 2 has some like slightly different. But from my own experience, Arbitrum is like has better solution. In terms of integration. But I think after Bedrock update on Optimum, and it also supports it as well, but it needs some time.
Yeah, actually on that point, because I was studying the different support across layer 2s for account abstraction, I don't really see any like official support type of announcement from like Optimism. So you're saying that Bedrock has like official support for that, and what's it gonna be like? Yeah, it's like my follow-up question.
Sorry, can you repeat your question?
Yeah, sure. Yeah, because I didn't actually see any official support from like Optimism for account abstraction. And you mentioned there's going to be a Bedrock upgrade. So could you elaborate on the type of support Optimism is going to provide for the account abstraction?
Yeah, I think after Bedrock, if the node supports the customer error, and then we can run the bundler service on the Optimum, and then we could be able to use the ERC4337 on their update. Right now, because it doesn't support the customer error message, and their node only return error code without elaborate the technical customer error. So it's very hard to write the bundler service on the optimum. Maybe I can drop the link on their like discussion.
Yeah, that'll be helpful. So it sounds like it's not an upgrade like specifically for account abstraction, but just fixing some like adjacent issues that can improve the development experience.
Yeah,
Okay.
correct.
Okay, and we have one more question in the chat. So a very enthusiastic user is asking if they can get a trial of the SoulWallet. So how's your take on that?
Yeah, because right now, because SoulWallet also facing a lot of like the challenge we are talking about, because I think it's like not ready for like right now we can have an alpha trial, but it's only a small group, and later we could like if you're really interested, you can build from our source code because all the code is open source. You can build yourself. But for the alpha user, because the wallet has to manage the money, and we need to have a good solution for all this problem. And yeah, if it's solved, then we could let more users to try our product.
Definitely looking forward to that. And another question from Tomo is that who will make the nodes network, basically the RPC for the AA bundlers?
Who will make the node? You mean the bundler software, or like right now? I think there are a lot of like project working on the bundler service as long as they meet the protocol standard, and we can it's just like Ethereum native client, so it could have the multiple team on working on different client like Prism or like Nevermind. So if there is some other project to support the A service, everyone can run the bundler service. It's a decentralized service.
Yeah, and that's also answering Zhihao's question, who asked like who's running the bundlers, and if there's like more implementation, basically everyone can fork the code can run the bundler. And there's a follow-up from Tomo. So the question is, does the bundler have to work with RPC that doesn't support custom revert? Sounds like very technical. So what's your take on this question?
I think that it needs the node update. If you could modify the node, it's technically possible to run the bundler service. Yeah, but in the optimum specific, after their bedrock update, we can easily decode the customer errors. But if you like a hacker, you could modify like because the customer server is only like a ABI decoding thing, and to make it easier to debug.
I see. So is that just a problem for Optimism or also for the other layer 2s as well?
Other layer 2 support the customer errors.
I see. That makes a lot of sense. And I think just circling back to one of your earlier answers, so in terms of using the bundler service, I see like SoulWallet is using a fork of the ETH infinitism, like the official implementation for this. So I just wonder what's like the trade-off between building your own bundler, because I saw like some other wallets been doing that versus like using a fork from like an existing provider.
Yeah, I think the bundler is because SoulWallet is more focused on the smart contracts side. We could we are not limited to using the official bundler or other bundler service. And because right now we are still early, and I think in our allocation is more on the smart contract side other than like the bundler service, because the bundler is like a separate from the smart contract side. We could use like a different choice, or we could implement our own bundler in the future.
That definitely makes sense. Let's see if there's any more questions. I don't think there's any other questions, so I'll be filling the gap. Hopefully you don't mind, but I have a question regarding, because earlier you mentioned that the EOA accounts, they don't have as much of a challenge in terms of like cross-chain messaging. So I just wonder, like, why is that the case that it's more of a challenge for like smart contract wallet?
Yeah, because
and
it
for the
could,
address generation, yeah.
yeah, because it could be a UX problem if we don't have like the cross-chain state synchronized solution. For example, we could have like in my slides, if there is no like a state synchronized solution, and we have the user want to do social recovery on their smart contract wallet, they have to recover one by one and ask Guardian to sign their recovery request on each chain. So it's a huge UX challenge. And this could be a problem for the smart contract to have the better user experience.
Yeah, that definitely makes sense. And also on the middle of your slide, you mentioned like the create to opcode. I wonder if this is like the same for the EOA versus like the smart contract wallets in terms of like the difficulty of implementation.
Yeah, but there is a solution to deploy the same address on different layer twos, but by using create to, it has to meet certain criteria. For example, the initialized code has to be the same, but for the smart contract wallet, it has to have some initialized setting, which to prove you are the owner of the smart contract wallet. Otherwise, if we don't add this check, other guy could front run your address on different layer twos. So in order to have the same address consistency, it could be challenged. As I mentioned, if the user have the social recovery feature, if they replace their key after they using their smart contract, for example, 2 years, and later there is a new layer 2 appears, if the user want to have the same smart contract address on the new layer 2s, however, they already replace their original sign key using social recovery, it's hard to deploy the original address, but it's still possible, but it's not a good idea to deploy using the previous initialized code because your key probably get compromised or get hacked. And it need to find a way to solve this address consistency issue. I think Gnosis Safe doesn't enforce user like to think they have the same safe address across different layer twos. But we are still thinking about if we, in the SoulWallet, if we let user know they have a different address across layer twos, or we are giving users the idea, they assume they always have the same address. So there is some trade-off for that.
Okay. That's definitely makes sense on the technical side. And we have another question from SAS. So he asks, do you see that user ops with alternative mempools will create a new playing field for the MVV searchers? And how do you think that's going to be?
Yeah, definitely, because the bundler is like a block builder in the MEV. They could like technically reorder some user operations, could create some MEV opportunity, but it also encourage other bundler to have their better solution, or because the they can maybe create a high competition for bundler to chase each other in order to have this MEV.
Yeah, that makes sense. In terms of the mempools, to my understanding, most of the wallets are currently using the private mempool, and I don't see like a public one yet. When do you foresee this is gonna happen? Are they like still making the standards, or what's the process for that?
Yeah, right now I think all the bundler are using the private mempools, but there are some projects already create like propose some solution to support the peer-to-peer user operations. But I think it's also a challenge because user operation, the public mempool is more like the public mempool on Ethereum natively, and we could use Flashbolt to protect the user operations. Maybe we could have some Flashbolt-like solutions for public mempool on user operation, but I don't know the solution. Yeah,
definitely makes sense. And no more question from the chat, but I think earlier you mentioned in terms of the Guardian implementation, there's like a separate contract for that. I just wonder if that's like the common solution across different wallets, or if that's like unique to SoulWallet, and what's like the design principle behind it.
it is not a specific solution for the SoulWallet, but we just borrow the concept from the multi-sig wallet and using this multi-sig recovery module using with the Guardian service, because we don't want to store the Guardian address directly on chain, and there is a way to abstract away the Guardian address. It's only needed the Guardian address when it actually performs the reveal, like performs the social recovery. Before that, other third party cannot see your Guardian, who is your Guardian, by checking the contract.
Is that because only the hash of the Guardian address is stored?
Yeah, you could think it's a hash of the Guardian, but it has verification logic on this hashed address.
I see. And are all of these modules like smart contracts on chain, or what's their format?
What do you mean the format? It's like
yeah, the module is like a smart contract on chain.
Yeah, it's like a module.
I see. Okay, wondering if there's any more question from the audiences. Feel free just to type in the chat, or you can just unmute yourself. Okay, I'll give a final count of 5, and in case there is any more question, we can just call it for the day, because we're already like 4 minutes over.
Okay.
Okay, I guess there's like no more questions. And it's been a fantastic discussion and amazing question from all of you. And thank you so much for coming. And just give the final advertisement. Antalpha Lab is having the Hacker House again in Montenegro from May 18th through like May 24th. The sign up link is already like open on Twitter. We sent you the link earlier in the chat. I'm gonna paste it here again. In case you have some awesome ideas and want to come to the AdCon or some events at Montenegro at the same time, definitely feel free to sign up. We are still taking actively interviewing people right now, and definitely also join our like Telegram group. We have like amazing discussion over there. So that should be it. And thank you so much for SoulWallet. Thank you so much, Wei, for being here for a wonderful session.
Okay, thank you. It's really honored to have this session. And
yeah, definitely. Okay, take care, everyone. Have a great night or day.
Okay, bye.